Welcome. Today I would like us to talk about or discuss back titration. Let us discuss back titration, and we will start by understanding what is back titration. So a back titration is a method of determining percentage purity or quantity of a substance by reacting it with a standard solution, and then titrating the remaining solution with another solution, e.g. we can talk of an alkali. Remember, when we were in Form 1, we said that an alkali, this one is a soluble base. So we are saying that we want to determine the percentage purity or quantity of a substance by reacting it with a standard solution. A standard solution is a solution whose actual concentration is known. So we can take here, for example, e.g. an acid. And then, if we take this one to be an acid, it is important to note that the moles of the acid that reacted with the analyte is determined by subtracting the remaining moles of the acid from the original moles of the acid. And then the moles of the acid, or rather the moles of the analyte, that reacted can be found through stoichiometry. So in this case, we are going to determine the moles of the acid that reacted with the analyte, and then we can be able to see the moles of the analyte that reacted by doing what we call stoichiometry. In other words, by writing a balanced chemical equation. So it can be seen that a back titration is a very indirect titration because it involves two steps. It is a two-step analytical technique. First of all, we have to do the reaction of the substance with a standard solution, and then we have to titrate the remaining solution. This remaining solution is the one that is in excess solution. We have to titrate it with another solution like an alkali. Let us do an example involving back titration for us to be able to understand better. In this question, we have been told that you are provided with number 1, solution A containing 5 grams of the mixture of sodium carbonate and sodium chloride in 1 decimeter cubic solution. That is, in short, that one is 5 grams per decimeter cubic. And this one we are being told it contains sodium carbonate and then plus sodium chloride. Okay? And remember, this one is grams per liter. This is grams per liter because we said 1 decimeter cubic is equals to 1 liter, and it is also equals to 1,000 centimeters cubic. And then we also have been provided with 0.1 molar sulfuric 6 acid. Remember, this one is molarity, capital M, molarity. And molarity means moles per liter. In other words, that to say that 0.1 moles of sulfuric 6 acid are contained in 1 liter, and it is called solution B. And then they are telling us, given that 5.6 centimeters cubic of solution B was required to completely react with 25 centimeters cubic of solution A, then calculate the number of moles of solution B used. So to begin with, it is this volume of solution B that was used. And initially we have 0.1 molar sulfuric 6 acid. Sulfuric 6 acid. And this we have said it means that 0.1 moles of sulfuric 6 acid are contained in 1,000 centimeters cubic. So we want to know how many moles of sulfuric 6 acid are contained in 5.6 centimeters cubic. So this one, we can do it by cross multiplication. That is 1,000 times x equals 0.1 times 5.6. So for us to get the value of x here, we shall have x equals 0.1 times 5.6, or that divided by 1,000. So that one becomes 0.00056 moles. And then in part B, they are telling us we calculate the number of moles of sodium carbonate in mixture A. Now, for us to calculate the number of moles of sodium carbonate in mixture A, we have to understand that in this mixture, we have got sodium carbonate and we have got sodium chloride. The moment we add this acid to the mixture, what is important to note is that it is only sodium carbonate that is going to react with the acid. The sodium chloride will not react. And the reason behind that is that sodium chloride is a neutral solution. And being a neutral solution, it means that it does not react with bases, neither does it react with the acid. So the moment we introduce our solution B, that is our sulfuric 6 acid, in this mixture, it is only going to react with sodium carbonate, but it will not react with sodium chloride. We have said the reason is because this sodium chloride is a neutral solution. That means if we write a chemical equation for this chemical reaction, we should have sodium carbonate in solution to react with sulfuric 6 acid This one gives us sodium sulfate, of course, plus water. equals plus carbon 4 oxide gas, because we said that when we react a sodium carbonate with an acid, we get a salt, we get water, and we also get carbon 4 oxide. Now that means using this equation, because it is balanced, I can be able to get the mole ratio. The mole ratio, sodium carbonate is to sulfuric 6 acid. It is 1:1. It is 1:1. Meaning that if these are the moles of the sulfuric 6 acid, I can then be able to get the moles of the sodium carbonate by taking 1 times x equals 1 times 0.00056. And this is the same as 0.00056 moles. 56 moles. And then in the next question, they are asking us that we calculate or we find out the molarity of sodium carbonate in mixture A. Remember, this term molarity, it means that we are talking about of concentration in moles per liter. And we have found that 0.00056 moles of sodium carbonate, they are the moles that actually were found in mixture A. And these moles of sodium carbonate, they are the ones that were contained in 25 centimeters cubic because they neutralized the acid. That means that 0.00056 moles of sodium carbonate are contained in 25 centimeters cubic. We want to know how many moles of sodium carbonate are going now to be contained in 1 liter, because molarity is concentration in moles per liter. So how many are going to be contained in 1 liter? This one we can get it by cross multiplication, because it is 25 times x equals now 1000 times 0.00056. Now this one means that x can be calculated as 1000 times 0.00056, and then all that divided by 25. If we do this calculation, we find that 1000 times 0.00056, and then that answer divided by 25, it is giving us 0.0224. Now, because we are being asked about molarity, this one is going to be capital M. Capital M. Now, it is good for students to note that if you are not good in writing a good capital M, you can as well write here moles per liter. You can as well write moles per liter to stand in for this capital M. But if you're good in writing a good capital M, then you are good to go. And then they are asking us to determine the percentage purity of sodium carbonate in mixture A. Now, it is important for us to understand that in this sodium carbonate, when you are finding the percentage purity, you have to find out first of all the mass of the sodium carbonate that reacted, and then once you find the mass, you compare it with the mass that was there initially, and then you do a multiplication with 100%. Now remember, finding the mass of 1 mole of a substance is the same as finding the relative formula mass of that substance, and then you express it in grams. Now, sodium carbonate is written as Na2, then CO3. Remember, the atomic mass for sodium is 23, that one for carbon is 12, and that one for oxygen is 16. So, the relative formula mass of sodium carbonate is 23 times 2, then plus 12, then plus 16 times 3. And this one becomes 106. So that means that 1 mole of sodium carbonate has, or rather it contains 106 grams. Now, we will be asking ourselves, what about 0.0224 moles of sodium carbonate? They are going to be contained in X grams. So once again, we can find out this one, because it is just 1 times X equals 0.0224 times now 106. And this one becomes 0.0224 times 106. That is 2.3744 grams. But the question is the percentage purity. The percentage purity. So I have to take, this is the mass of sodium carbonate alone. Now I have to take the mass of sodium carbonate, I divide with the mass, the total mass of the mixture, then I multiply by 100. That is 2.3744, all that divided by the total mass of the mixture is 5, and then I multiply by 100%. So this one I divide by 5, and then I multiply by 100%. So the answer becomes 47.488%. 47.448%. That is the percentage purity of sodium carbonate. And then moving on, we are being told to find or to calculate the number of moles of sodium chloride in mixture A. Now, using the first principle approach, now the formula for sodium chloride is NaCl, and the atomic mass of sodium is 23, and the one for chlorine is 35.5. So that means if I want to find the relative formula mass of NaCl, that is the same as 23 plus 35.5. This one becomes 58.5. And hence we can say that 1 mole of sodium chloride contains or has 58.5 grams. Now, remember, in this case we have seen the mass of sodium carbonate and we have the mass of the mixture. That means that if I take 5 grams, I subtract the mass of the carbonate, I can be able to see the mass of sodium chloride. So the mass of sodium chloride it is 5 minus 2.3744. So now that means 5 minus 2.3744, which becomes 2.6256. Now here I can now be able to ask myself, if 1 mole, if at all 1 mole of sodium chloride contains 58.5 grams, then how many moles of sodium chloride are now going to contain 22.6256 grams? So it is 58.5 then times x equals 2.6256, then multiply by 1. If I divide both sides by 58.5 and here by 58.5, so the value of x shall become now 2.6256, then I divide by 58.5. So this one, it is 0.0, then 4, then 8 moles. 8 moles. In cases where you have a very big number of moles, or number of moles that have got so many decimal places, you can as well write your answer correct to 4 decimal places. You can as well write your answer correct to 4 decimal places. Like this one can as well be written as 0.0449 moles. 9 moles. And then we are being asked to calculate the molarity of sodium chloride in mixture A. Now remember, these moles that we have seen here, they are going to be contained in this volume. They are going to be contained in this volume. So we will be asking ourselves, because these moles of sodium chloride are contained in 25 centimeters cubic, and the question is asking us to find the molarity. And we have said that molarity is concentration in moles per liter. So we will be asking ourselves that if 0.0449 moles of sodium chloride are contained in 25 centimeters cubic. So the question is, how many moles of sodium chloride, now molarity, concentration in moles per liter, now are going to be contained in 1,000 centimeters cubic. Now 25, this is 25 times x equals 0.0449 times 100. Now that means x equals 0.0449 times 1,000, but all these divided by 25. Now it is 0.0449 multiplied by 1,000, and then you divide that one by 25. That one becomes 1.796. Now this one, because it is molarity, you can as well write it as capital M, and just like I have said, instead of writing a bad capital M, or rather even you are not sure about your capital M, you can as well represent this M with moles per liter, because molarity is concentration in moles per liter. Thank you so much. Continue following us for more videos, and I am thankful for your continued support.